Good morning and welcome to this second edition of Coffee Chat with Cricket Liu. I'm Krupa Srivatsan, Director of Product Marketing here at Infoblox, and I have with me the one and only Cricket Liu, Chief DNS Architect and the author of DNS and Bind. Welcome, Cricket.
Thanks, Krupa.
In the previous edition of Coffee Chat with Cricket, we covered some of the basic aspects of DNS security, threat intel, RPZ, threat intelligence and analytics, and things like that. In this edition, we thought we'd do something different. We have asked you, the audience, and the registrants to send us your questions so that we can spend a lot of the time today answering some of the questions that you did post. And so that's what we're going to do for about 30 minutes or so here. So Cricket, should we just get started?
Yeah, so we had a backlog of questions from our previous event. So why don't we dive into those and see if we can address those. And of course, we would encourage anybody who's watching to send us your questions as well. We'll start off with some of these, but we would love to take questions live too. So one of the questions that we got, I think actually a few times in the last event, was how does the Infoblox Active Trust Cloud solution compare with Cisco Umbrella?
Yep, we get that question a lot, as you can imagine. So Cisco Umbrella, for people who know or don't know, it's the cloud-based SaaS DNS security solution that uses threat intelligence to block any devices from going to known bad destinations on the internet. So one of the ways that Active Trust Cloud and Active Trust, the Infoblox solution for DNS security, is more differentiated is that the Infoblox solution actually offers a hybrid model. So customers can have an on-premise deployment and infrastructure. They can have the cloud-based solution for protecting their remote users and remote offices. And the two components work very closely together. They're tightly integrated. They share data seamlessly. And they integrate with the rest of the on-premises ecosystem. So that's one of the ways that Infoblox solution is slightly more differentiated. The second aspect, which is really important, is detecting the zero-day threats or the advanced threats like data exfiltration, DGA, fast flux. So many of those threats, it's hard to detect using just threat intelligence and RPZ feeds. You need something more than that. Right. So what the Infoblox solution, Active Trust Cloud, does is it checks for patterns of malicious behavior on the DNS queries that are going out to the internet using analytics and machine learning, right? So we can check for patterns like presence of data in the queries, activities related to DGA, fast flux, and the reason that this is important is because the destinations may not be classified as bad just yet, so they may not show up in any threat feeds.
Right, they don't have a reputation yet.
They don't have a reputation associated with it yet. So for detecting those type of threats, you need an analytics-based module, which Infoblox provides. So I would say kind of the hybrid approach, the analytics, and then also we integrate with a bunch of the stuff on the ecosystem on premises. So we can cover that later, but that's another differentiator for Infoblox.
Okay, great. Yeah. Well, I know that came up several times, I think, in the last coffee chat. Yeah. One thing that I guess I should probably address here is somebody would like to know my thoughts on the future of DNSSEC and DNS over HTTPS. Okay. We've gotten a fair number of questions about DNS over HTTPS, yes, as well as DNS over TLS, which are called DOT and DO for short, which are kind of funny little acronyms. That I think is a really interesting question. So DOT in particular was designed to solve the sort of last mile problem in DNS. Okay. Namely the channel between the stub resolver and the recursive DNS server that it communicated with was really in the clear and subject to snooping, potentially modification of responses or queries. We see that, for example, behind the Great Firewall of China. Yeah. Responses are routinely spoofed to stub resolvers, causing all kinds of problems. Yeah. And so since TLS existed, transport layer security, as a standard way of securing a communication channel like that, they just figured, well, let's run DNS over TLS. Yeah. So DNS over TLS is, I believe, a standard now. People are beginning to use it fairly widely. Yeah. And actually, Infoblox is working with the Internet Systems Consortium, our longtime partner and the developer of Bind. They'll be adding support for TLS, I believe, in the next year.
Yeah.
So that's really good news. And it addresses, like I said, a long-standing problem, a long-standing vulnerability in DNS. DOE is a little bit different. The reason that the working group that developed DOE began work on it was because there are situations in which middle boxes, customer premises equipment, or stuff on a carrier network, or stuff run by a government might modify DNS queries or DNS responses. And basically, this is sort of a shell game or needle in the haystack approach. They said, well, if we just tunnel DNS over HTTPS, it's going to be very, very difficult for folks to distinguish the DNS traffic from any other web traffic. And certainly a perfectly straightforward thing to do to encapsulate DNS in HTTPS, but it does bring up some issues. There is an experimental implementation of a DOE client in some builds of Mozilla's Firefox browser, for example. And what Firefox does, if you use the DOE functionality coupled with something called TRR, Trusted Recursive Resolver, is that it ignores the local system's stub resolver configuration and just goes straight to Cloudflare. And Cloudflare, of course, runs 1.1.1.1 and sends recursive queries over DOE to Cloudflare's DNS infrastructure. For consumers, particularly people who might live in a country where communications is routinely snooped and potentially modified, that might be a really, really good thing because there's less of a chance that any of your communications are going to be intercepted. Within an enterprise environment, though, that poses certain problems because what that means is that you're circumventing any mechanisms, any security mechanisms that the organization's local DNS infrastructure provides.
Right, yep.
And that might include RPZ-based facilities. It might include analytics that people are doing on passive DNS. You might be bypassing a whole lot of internal zone data as well that you need to access internal resources. So DOE is I think, a little bit problematic in certain settings.
Right.
I wouldn't say across the board it is, but certainly within the enterprise, we have some customers who are concerned about it.
Yeah, I can imagine. Yeah.
Yeah. So that I think is going to be one to watch to see how DOE develops and how the browser vendors deploy it.
Yeah. Well, I can imagine how that could be something to watch out for.
Yeah. Well, I think we actually have a couple of questions.
Right.
That is fantastic. Let's see. So Byron asked, to maintain the security around DNS, what are some areas that you should check in a security audit? Okay.
So I think one of the things, and that's a great question, by the way. So I think one of the things that most companies don't realize is DNS data. Just by looking at the DNS logs, looking at the DNS data, you can get a lot of information about the device and user activity, right? Where they're going to in the internet, what resources they're accessing, how often they go to certain destinations, things like that. And so just by looking at the DNS data, you can actually do a lot of things from an audit perspective. And if you have like the really good reporting and enterprise grade reporting associated with DNS, it's easy to pull those reports out and then use it for audit purposes. So that's a great question, and I think we always recommend as best practice to have an enterprise-grade DNS DHCP IPAN that's constantly kind of reporting out on the activity, and in addition to the DNS security layer that we talked about, including RPZ and malicious activity. So your reporting can show regular activity, it can show malicious activity related to phishing or ransomware or whatever, and so that can be really good in terms of audit. I don't know if you had anything else to add for audit.
I guess I think of it in a couple of different ways. There's sort of securing your DNS infrastructure from attack, and there I think particularly of looking at any DNS servers that are directly exposed to the internet.
Yeah.
So external authoritative DNS servers, you want to make sure, for example, that they don't offer recursion. You want to make sure that the only zone data available from them is what you really want to publish. You want to make sure that the systems they're running on are hardened against attack, unless you're running on appliances, in which case might make that a little bit easier.
Yep.
On your internet forwarders, which are the recursive DNS servers that query authoritative name servers on the internet directly, you want to make sure that they're authorized to go through your firewall and get out to the internet, and that they're running the latest and greatest versions of whatever code you happen to be running. If you can turn on DNSSEC validation, of course, that's a good thing too.
Yeah. DNSSEC is a good point, I think, that you brought up. And I think coming back to the Umbrella question, Umbrella, I think, does not support DNSSEC. I think it's really important to support DNSSEC, as you would know, because of the way it can help prevent attacks like cache poisoning and make sure that the DNS queries are validated and things like that. So that's a really good point that companies should look at a DNS implementation that supports DNSSEC.
Yeah. In fact, I think once upon a time I probably did a talk or two on securing DNS infrastructure. And for Byron, if you're out there watching, then please look those up. There used to be I think I had a 10-point or a 12-point talk on all the different things that you might do in order to secure DNS infrastructure.
Yeah.
So hopefully those are out there. I'll look much younger in those videos than I do today. Here's another one which I thought was interesting. How to use, we'll rephrase it. How could you use Infoblox as a CA, so as a certification authority? Okay. So that, I think, is a question about TLSA records and about DANE. And I don't know if we talked about that at all in the last...
I don't believe we did, so maybe it'll be good to get into that a little bit today.
Yeah. DANE is a pretty interesting new application of DNS. It's designed to solve a problem with X509 certification infrastructure. And basically the problem is that most web browsers today trust too many different CAs. Dan Kaminsky, of course, who's a very well-known security researcher, did some investigation into this. I think he found that one of the major web browsers, maybe it was Firefox, trusted something like 2,500 different CAs, which is crazy. You don't really trust all 2,500 of these different organizations to issue certs. Moreover, one of the issues is that every one of these CAs could issue a cert for anything, right? If you trust, not to pick on anybody in particular, but say, the Chinese national CA, or I don't even know if there is such a thing, but if you trust them, then you also trust them to issue a cert for, say, www.google.com, right? Or for www.infoblox.com or something like that. Whereas, of course, Infoblox would intend only to authorize certain CAs, CAs that we're a customer of, to issue our certs. So the IETF came up with this application of DNS that's called DANE, which stands for DNS Authentication of Named Entities, I think. And one of the ideas behind DANE is that you can publish these special resource records in DNS called TLSA records. And the TLSA records can do things like say, this is my CA. Right? So an organization like Infoblox could say, we use, I don't know who we use actually, but we use Symantec or we use Komodo or somebody like that. And that way, a web browser that was trying to reach our web server and was presented with an X509 cert could see, okay, this X509 cert was issued by this CA, and then could check the TLSA record from www.infoblox.com and say, yep, that is their authorized certification authority, or no, it isn't, which is a pretty important thing to be able to do. And in fact, TLSA records are even versatile enough so that you can even forego a CA, and you can generate your own keys and publish them in TLSA records. So I think that's what this gentleman was talking about. So it's pretty cool stuff, but the one thing I will say is that if you are going to use TLSA records, you should definitely sign the zone that you're going to put the TLSA records in. Right? Because you're going to be if you're going to be putting very, very valuable data out there in your DNS zone, and then you want to be able to protect that data. You want people to be able to cryptographically validate that.
Absolutely. Okay. Those are some really interesting questions, and I think, like you said, we didn't have time to go into it in the last time around, but I'm glad we're getting kind of a different set of questions this time.
Let's see. This is kind of an interesting general question. Somebody said, how can I turn DNS into my most valuable defender and enforcement point on my network? That sounds like one that we wrote. It's not, I swear. This is actually directly out of the spreadsheet that we got from the last coffee talk.
Yeah, I think that's, but I think it's a good point, right? So most organizations don't realize that DNS can be that first line of defense. Customers or organizations invest in defense in-depth tools, next-gen firewalls, web gateways, sandboxing, endpoint security, you name it. But I think DNS is a unique element in a network because they need it for connectivity anyway. Everybody needs it for connectivity. It's ubiquitous in networks, right? It's in different points in the network. And the other thing that most people don't realize is it's actually very easy to add security to DNS using RPZ feeds, using analytics. And a DNS appliance can actually consume a lot more threat feeds, a lot more indicators of compromise. You can fit that into a DNS box as opposed to like a next-gen firewall, for example, right? So there's scale. Customers can get scale in terms of DNS securing the entire infrastructure using DNS.
Right.
It's simple to implement, like I just mentioned. So, you know, using DNS as a first line of defense, what customers can get from that is they can offload you know, some of the work from these more expensive gateway solutions and perimeter solutions and put a lot of that in features and implementation into a DNS layer. So now those perimeter security and gateways can be focused on doing more deep inspection and things like that. So so that's why I think using DNS as an enforcement point is a cost-effective solution. It's also a very powerful solution, given that how it's ubiquitous in today's networks.
That's right. You already have the infrastructure.
Exactly.
You have to have DNS servers out there on your network. They're already distributed across your network. And if you can instrument them to do additional things, then you know, so much the better.
Exactly.
Right?
Exactly.
The one thing I think I would say in answer in response to the question that this person asked, he talked about turning it into his most valuable defender. I think we recognize within Infoblox that as much as we might like to believe that DNS servers are the most valuable security enforcement point on the network, we really are just one piece of the puzzle, and there are lots of very, very important components. There's your internet firewall, there are IDS and IPS systems and so on, and then we have to play within this larger ecosystem. And we have to communicate with them. For example, sometimes another security system might query us and ask for context about a particular IP address or a particular MAC address, and we can provide them with that context because of what we do, because of our role in the network. But we certainly are not the be-all, end-all security solution.
Absolutely, yep. And as you mentioned, we have to play nicely with the rest of the ecosystem, right? Because at the end of the day, no one security solution is going to catch everything. And like you said, everybody needs context around threats so that you know exactly which ones are important to address first, right? So we can give that context. We can give the context because we are the DNS, DHCP, and IPAM solution in the networks. We know kind of what type of device is infected. We know where it is in the network. With AD integration, we know who it's assigned to. Right? And we have a lot of this historical information that we talked about earlier, so we can send all of that context to a vulnerability scanner, to an IDS IPS device, to the SIM solution for more analysis, right? So when security ops teams who are obviously always struggling to find more resources and they're short-staffed, they need more skilled resources, and they're also always behind on addressing the threats at a timely manner, right? One of the top things that I keep hearing about from when I do customer events is, how can we improve our incident response time? So the context that we can provide from a DNS DHCP solution can actually help them prioritize, right? Which ones are important, which ones should be addressed first. So that's a critical element as well. And then the other thing is also automation. So automation can alleviate some of the skills shortage issues that security teams face. So when we see changes in the network, when we see security events, right, we can automatically trigger a scan from a vulnerability scanner, right? We can automatically tell the NAC solution to knock that device off the network and have it cleaned up before allowing it back on the network. So some of these orchestration and automation capabilities can really help alleviate the operational issues that customers may be facing.
Right, and we sort of play a different role there depending on what it was that we were integrating with. For example, in that example that you gave about quarantining devices, I think we can do that with like Cisco ICE, for example, with our integration with there. So there we could detect an infected device because of, for example, a query that it sent that actually matched something on an RPZ feed. But then we turn over that information to somebody else to actually do the enforcement. In other cases, we might just augment data. In other cases, I imagine that we could probably ourselves prevent somebody from getting a DHCP lease or something.
Yeah, exactly. And then the other thing from ecosystem perspective is threat intelligence, right? So the other aspect that we've seen is many companies use threat intelligence in different parts of the network. They may be using a different set of data on their firewalls. They may be using a different set of threat intel data on their SIMs. So it's kind of siloed, right? So they're not really working off of the same source of truth, and they're not really getting the benefits of having an aggregated threat intel platform. So one of the things we can help with is putting all the threat intel that they already are subscribing to onto one platform, the Infoblox Tide platform. Obviously, we can put our own threat intelligence data as well from our threat research team. And what customers can do is take that aggregated threat intel and push it down to not just a DNS security solution, but also to the other security tools they're using in the ecosystem, like their firewalls and their SIM solution. So now they are getting the benefit of an aggregated threat intel data platform, and they're getting more efficiencies and eliminating those silos, so to speak, in threat intel.
Okay.
Yeah.
So we have one question here. The very first question, actually the dot and do question that I guess that was the second question that we took, mentioned DNSSEC, and I think I didn't really address it. And somebody else asked, why hasn't DNSSEC become more mainstream? So maybe I should talk about that briefly. And of course, this is my perspective on it, which may differ from the actual real world truth. But the way that I saw DNSSEC play out was that the very, very first versions of DNSSEC came out. That is the DNSSEC standard, and the very first implementations of DNSSEC in, for example, Bind 8.2 began to come out, and I think it was evident back then. This was, I think, the 1990s, that it was nearly impossible to administer, and there was going to have to be an overhaul. So I think not a lot of people did much besides sort of playing around with those implementations of DNSSEC in the lab. Then there was a later effort, sort of the second generation of DNSSEC that my old business partner, Matt Larson, and a bunch of other very smart people worked on, which resulted in, I think, a quartet of RFCs, 4032 through 4035, I think. At that point, there had been a lot more thought given to DNSSEC about how to make it more robust to address the problems that we saw when we were trying to initially implement the first versions. So everyone was sort of waiting around to implement until that happened, and then of course until the implementations caught up with that newer version of the specification. Even then, though, there were some holdouts. There were some organizations like VeriSign, for example, who said the cost of signing these very, very large zones that we operate, like COM and NET, is too high, and so we want what they called an opt-in facility, the ability to sign effectively part of a zone. So there again, we sort of knew, the spec's going to have to change again to accommodate VeriSign. So we're not really going to bother with the implementations, or administrators aren't going to bother with deploying these new implementations. So we've been through that many, many, many times, and that's made it difficult. It had people sort of standing on the sidelines waiting for the specifications to settle down, to really gel. And then at the same time, the implementations within Bind and within other software have been, initially they were very, very difficult. I remember writing the Security chapter, which contained the DNSSEC material for the 4th edition of DNS and Bind. And it was something like a 12-step process to sign his own for the first time. Almost all of it with command line tools and almost no automation whatsoever. And I thought, gosh, nobody is going to do this. Nobody in their right mind is going to do this because there's so much potential for something going wrong.
Right. I mean, manual steps are always error-prone, right?
Yeah. So, absolutely. Yeah. Absolutely. So I think a lot of people waited for the tools to improve, and maybe some of those people are still sort of waiting on the sidelines, thinking that the specifications haven't settled down, or that the implementations are still difficult to administer, and that's really not true anymore. I think at this point there's no good reason not to deploy DNSSEC. There's much better automation in the standard tools that you get with Bind, for example. They're much more mature, much easier to use. Infoblox and other competitors of ours have invested a lot of effort and a lot of resources in automation as well. So that, for example, if you go into Infoblox's NIOS graphical user interface and you want to sign a zone, well, you select the zone and then you click on a button that is helpfully labeled Sign Zone, and then actually you have to click Yes to accept the things that are going to happen behind the scenes. But it's much, much simpler now, so I would encourage those of you who haven't gone to the trouble of signing internet-facing zones to at least experiment with it, at least grab a little vanity zone that you might have that's not being used for much else, and sign it, gain some operational experience with managing a signed zone, turn on validation too.
Yeah, do you see certain types of industries adopting it more than others, DNSSEC?
Definitely, definitely. I mean, if you look at verticals, for example, within the U.S., there's this hotspot of DNSSEC adoption in the U.S. federal government because there was an OMB mandate to deploy it. So there's a lot of deployment there. Outside of that, in sort of the generic top-level domains like Common Net, it's a very, very small proportion of zones that have been signed. But if you look in various country code top-level domains, they've had a lot of success. There are TLDs that have very solid double-digit percentages of subdomains that have been signed. So Swedens.se has a very high percentage of subzones that were signed. Belgium's.be, Bulgaria's.bg. I mean, a lot of places like this, countries that you wouldn't necessarily think would be leaders in the adoption of DNSSEC really are. I don't know exactly what they're doing in all cases. Sweden was very early to the game. I remember they hosted a DNSSEC workshop that my old business partner and I went to 2 decades ago. But so it is kind of irregular, I guess, if you've looked at DNSSEC adoption across the internet.
Okay, all right, very interesting.
Should we see if we have any more live questions to take? Here's one from Armando. He said, is there a real security concern with AWS FCS publishing RFC 1918 IP space in private DNS resource records? That's a very specific question, isn't it? I would say that the one caveat about RFC 1918, which is internal private IP addressing, RFC 1918 itself says you're not supposed to add resource records that point to RFC 1918 space if that stuff is publicly resolvable. It's not any good to anybody. It makes sense, right? If somebody queries your name server across the internet and looks up a domain name and you hand them back 10.0.0.1, well, they're not going to the 10.0.0.1 that you mean. So I'm afraid I'm not as familiar with this particular issue, this particular question as he might. But that's the one thing I think of when I think of RFC 1918 and DNS. Should we take one more question?
Yeah, I think we could take one more.
We're nearly to the end of our 30 minutes. Oh boy, so many questions, and a lot of these actually we've actually handled.
Yeah.
Oh, here's one. Okay, so somebody says, I am about to deploy DNS firewall, so response policy zones. Is there, or what is, the best practice for configuring SMTP or mail relay servers behind the DNS firewall? Should I take any special consideration or configuration for an email relay doing recursive DNS queries to an Infoblox appliance running DNS firewall. That's interesting. I would say that there's probably nothing specific that you need to do for a mail server. I guess the one thing that you might consider, though, is you could even plumb unique RPZ feeds into that recursive DNS server that it uses, ones that are specific to email. So if you wanted to go
you can put in the custom RPZ feeds.
Absolutely. I mean, there's this whole ecosystem now of RPZ feeds coming from different organizations around the world, and some of them are specifically about combating things like phishing and spam and stuff like that. So you might look at a particular RPZ that you could plumb into just that one recursive DNS server. Maybe it wouldn't be needed on all the rest of his DNS infrastructure.
Right. And I think we make it easy for customers to put in their custom RPZ feeds in addition to the threat intel data that we put into the boxes as well. So it should be fairly very easy to do.
I would think so. Yeah, absolutely.
All right, great. So I think we are almost at the end of the of the session. If we didn't get to your questions, we will answer them offline. But thank you so much for joining us today. A couple of things before we close. So if you want to find out how exposed you are or your organization is to DNS-based threats, or whether you want to check whether you've done everything you should be doing in terms of implementing security in depth, there is a really cool risk assessment tool that we have launched recently. And it just asks you a bunch of questions, maybe 10, 15 questions, and it'll give you a risk score. And then there's also a risk index that's been calculated on a daily basis. Oh, cool. So customers can figure out their own risk level, but also they can compare it with the rest of the industry to see how they fare. And then there's a nice detailed personalized report where they can get some best practice recommendations on improving their security posture. So I think that's a nice tool to leverage. You can go to infoblox.com/threat center to get access to that tool and just take the survey. It's a nice chatbot interactive interface, so you'll have some fun with it. And finally, this is a coffee chat, so we do want to give our viewers and our audience a Starbucks gift card, which they can leverage and enjoy some coffee.
All right.
So thank you so much, Cricket, for the session today and answering all those questions. And thank you, viewers, for joining us today.
Thanks, Krupa.